So, all right, awesome. Well, guys, thank you very much for giving us the opportunity to speak with you today. I know you guys typically hear a commercial about the firm that's presenting to you, and I will promote our firm certainly, but I'm going to do it in a subtle way to where you won't even know I'm doing it, because that's my goal. So, so next slide, please. So this one's titled Life After School, Discussion of Trends, Collaboration, and What to Expect. And it's just kind of a general thought of what we have. We talk about trends that are influencing transportation engineering. You know, first we're going to introduce B&N, we're going to introduce ourselves, talk through some of these trends, and then tie it up with what does this all mean. So hopefully trying to position you, you know, if you're thinking about what you're going to do post-school, certainly in the transportation engineering aspect, I think this will hopefully be beneficial. If you're looking at something other than transportation engineering, I think a lot of this may still apply. So next slide, please. So let me first start out with B&N as a whole. We're about 400 folks strong, 23 offices in 10 states. I always have to remember that because we literally are just adding our Washington, D.C. office as we speak. For those that are really strong in geography, this is not what our country looks like necessarily, but we pulled it apart to put it together so it looks more representative on a slide. 4 offices in Ohio. Columbus is our headquarters. So we are 10 minutes from OSU campus. They're at Bethel and Reed Road in Upper Arlington. So we are a full service firm. We do roadway, we do bridge design, we do traffic analysis, traffic planning, we do planning, we do safety analysis, but we also do environmental engineering, we do wastewater treatment plants, we do site civil design. We don't do construction inspection yet. However, if anybody on this call is interested in starting that practice, by all means, let me know, because we are also in a growth mode and we are willing to take small bets to try to build our practice. So next slide. So the 2 SAPs you have to listen to for the next, what, 4.5 hours, right, Mr. Reinhardt? That's what you told me. Just kidding. But so myself, I'm Brian Toombs. I've got 22 years experience. I'm a big project junkie. By that, I mean anything that's really big, complex. If you look around Columbus, Ohio, and you see orange barrels on the big interstate jobs, there's a good chance I had something to do with it. So you can swear at me as you're driving and you see an orange barrel, but I call it job security. I'm an interchange specialist, roadway traffic manager in the Columbus office. I graduated from the Ohio State University, and you can see by my background, hopefully you can, in 1998. And I also teach Civil Engineering 5730. So that's the Highway Geometric Design class. For those that have not taken it yet, I encourage you to, but maybe wait till you listen to see what we talk about here before you sign on the dotted line. That course is offered in the spring. So Danny, you want to introduce yourself?
Yeah, so like Brian said, my name is Danny Soroka. I also went to the Ohio State University. I graduated not too long ago, just back in December of 2016. So that puts me at almost 4 years at Burgess Niple full time. Prior to that, I had a couple internship co-op experiences with both B&N and Trans Systems, and I also was at ODOT for a little bit. I am also I could say I'm a big project junkie, but I mean, I've only been 4 years. I've gotten a lot of experience from small projects to big projects. Also around the Columbus area, I worked on the Smart Lane, the State Route 315 at North Broadway interchange project. Also, if you drive up and down 315 a lot, you probably saw a new bike path at Bethel Road. I played a big role in that one. So I've really gotten a good broad range of experience working here at B&N. I'm currently an OSU capstone consultant. So if any of you are in capstone, I may have met you before, or if not yet, I may meet you this semester. It's my 2nd year doing this. Just to go back a little bit, when Daniel was given a plug for ASCE national membership, I just wanted to reiterate that I'm not an ASCE member, but I'm in the Central Ohio ASHE section. We have people here in our office that are in ASCE, And just getting involved in any professional organization is really important just for networking, meeting other consultants and clients. And so I would strongly encourage that you guys try to stay involved. I was also a ASCE board member when I was at Ohio State. So looking forward to meeting some of you guys.
Yeah, since I sit on the table that looks at hiring people, I can tell you we look for things like that as part of your extracurricular, especially if you are building a national network, and especially if you can name drop a few folks, even if you're just making them up. I wouldn't know the difference necessarily, but being able to plug that is something very beneficial to you in your job search. So just saying hint, hint. So next slide. All right, so as promised, and if there's any structural engineers in the room, that's not a good picture right there. But let's talk about trends that are influencing transportation engineering for a second. So go ahead, Danny. All right, first trend is congestion, and it's increasing congestion. Vehicle miles traveled is going up. You may not be able to necessarily read this graph, but the y-axis, got to get my directions right, is billions of miles traveled, and the bottom or x-axis is years, and you can see it's just continuing to increase. And as traffic builds up, so does a lot of problems. So next slide. So with that comes innovation, and I always say innovation comes out of necessity. This is an example of that. So anybody who can recognize that as a diverging diamond interchange. The reason why this is a real benefit from a congestion standpoint is reduces the number of signal phases at the intersections. For those that do traffic engineering, signal phases, especially left turn phases, kill the operations of an intersection. Too many intersections close together cause some real problems, stop and go traffic on the arterial, that sort of thing. This one here is the first DDI in the state of Ohio at I-270 and Roberts Road. They're near Hilliard, Upper Arlington Range. We designed that. We've done the first one in Ohio, Michigan, Indiana, Washington, the second one in Kentucky. Notice, by the way, how subtle I am with the plug of how great B&N is. We've designed 21 of these in the country. But the real reason I'm showing this again is we have to get innovative when we think about how we're going to defeat congestion. The days of just simply building our way out of problems is not going to happen anymore. Perfect example that Danny brought up with 315. How many of you guys motor or commute down 315 on your way to class or back? The hospital curve, sharp horizontal curve, can't widen that. If you tried to widen that, you'd either take out a hospital or now Ohio Health's main headquarters, both of which would be a problem. So there's got to be other solutions that we can handle congestion. We have started looking at that at B&N with adaptive ramp metering, stuff like that, just to try to get better flow on the interstate. Next slide. So there you go. Some of the things that we talk about, again, being innovative is TSMO strategies. TSMO is Transportation Systems Management and Operations. It's one of those cool buzzword acronyms. Write that down, because as you go job searching, say the word TSMO, good things will happen. This one here is an example of ramp metering. What we're trying to do there is meter the traffic that's getting on the freeway to allow for better flow on the freeway. The next one shows variable speed limits and queue detection. Believe it or not, by reducing the speeds on a facility, you can actually get better throughput, more traffic through it. The reason's simple. If you got really high speed corridor and traffic has to come to a stop and then go, and come to a stop and go, problem is the first car in the line maybe slows down from 60 to 58 miles an hour. The 12th car in line slows down from 60 to 12 miles an hour, the accordion effect. And so what ends up happening is you get this uneven flow and a problem. So lowering the speeds could actually benefit that. And then Danny alluded to it, but part-time shoulder use, what that smart lane project that he was referring to is I-670, if anybody's ever driven it. From downtown to 270, you see these big honking gantries. This here is the example in a state up north. I am not allowed to actually say what state it is, but that is US 23 through there, and it is a part-time shoulder use. Lowered the speeds, allowed the shoulder to be used during the peak hour. So again, it's innovative ways to deal with congestion. Next. Another trend, safety, specifically fatalities in Ohio are going up. Now, granted, this graph only goes to 2017, but this graph doesn't look any different as we extend it to 2019. It's one thing when you look at it as a number, but think of it as your family member coming home. We want them to get home. Okay. So what can we do to design a facility to make it forgiving is what I like to call it. Crashes are going to happen, but what can we do to allow them to walk away? Truthfully, I don't care if your car gets busted up, but I want you to walk away, go home, and bitch about how bad that accident was. So the 5 common causes of crashes, go back to Dan, thank you. You'll notice the 2 of those we kind of have some control over. Roadway departure, certainly, if we can improve the geometry. The other one is speed. If there's ways that we can calm the speed, reduce the speeds, let's figure out a way to do it. You also notice how many of the percentage of crashes are at intersections, 22%. Those are the problems. So what can we do to improve the intersection flow, or what can we do to maybe reduce movements? So next slide. So image on the left, roundabouts. Those are huge safety benefits, because what happens at a roundabout is you slow down to come through it. Now, there's always a few of you in the audience that says, and I quote, I hate roundabouts, they're circles of death. I get it, okay? But I can honestly tell you it's really hard to see a fatality at a roundabout because you're traveling slow. Most of the time, maybe the property damage only crashes increase, but I don't care again if a car gets a fender bender, as long as you can get home. So what you see on the left are roundabouts. Those are huge benefits. B&N designed over 100 of these. Just put over 30 of them in the ground, including the 2 you see there in Hilliard. And feel bad for the Donatos right in the middle of that image there because, well, we went around him. So the image on the right upper corner is a restricted crossing U-turn or an R-cut intersection. The benefit of this is it takes away the left turns from the minor streets. So it still allows, there's some R-cuts that will allow a left turn in, but won't allow a left turn out. Again, from a standpoint, if you look at this intersection, one of the biggest concerns is drivers coming out of that intersection on the minor road having to look not only at the near side, traffic coming from their left, but also that far side. They have to be able to gauge the median width and then see, can they get a gap? So the challenge on that is if they're older people like myself, you know, they're sometimes not as easy to judge that and can lead to crashes. So let's get innovative, let's get creative about how we can address the safety concerns of intersections. And then for those that are traffic engineers, the Highway Safety Manual is a great tool for how to quantify our safety improvements. This is important because a lot of times we're getting innovative, we're getting out of the box, but now we have a mechanism for which to quantify and basically justify an improvement. At the end of the day, we are all moving towards 0 fatalities. So next. All right, hopefully you guys like to get active, get outside, ride your bikes. I can tell you when I was on campus, that was all I ever did was ride my bike. I got more car accidents with my bicycle than I ever did with a car, just the way it was. It had nothing to do with the 3 o'clock in the morning riding my bike time after a bar. But anyway, what you see here is an increase in the pedestrian and bicycle ridership. So the challenge with that becomes, how do we design a facility that accommodates both passenger cars, buses, semis, also bicycles and pedestrians? So another term I'm going to throw at you is complete streets. Use that buzzword as well whenever you're applying for a job, and it's a shoe-in. You'll get the job just because, you know, that's a very important topic. Complete street is not just a street that has shoulders and curb, but it's one that accommodates all users. So we've designed these as well at B&N because we are very focused on, as the population is starting to move back to the cities, how can we accommodate them safely on a project? So next slide. So I don't expect you to necessarily be able to see it, but if you want to squint and look, this is a corridor near Dayton, Ohio that we're doing right now a safety study on. This is a vehicle corridor that has a crap ton of pedestrian fatalities. It's one that you almost don't understand why. It's not on a campus. There doesn't seem to be at first glance, doesn't seem to be a massive issue, but yet there have been a ton of pedestrian fatalities. So we have taken on this corridor. Next slide. We've started looking at things like adjusting the typical section, taking away lanes, narrowing the lanes to reduce the footprint, the path that the pedestrians have to travel across the road. We created heat maps to identify where those hotspots are, and we've targeted those specific hotspots. So all of this, again, with the goal of, can we improve safety? Can we improve pedestrian safety in this particular case? So next slide. Another trend, technology. You guys all use it. I mean, look at what we're using right now. We have 21 people on this call from arguably 21 different locations, I'm guessing. You know, when you guys are driving, a lot of times now, when was the last time somebody printed out a map? Because now you use your phone, GPS. There's places where I don't even know how I got there because my phone just told me, turn left, turn right, turn left. If I lost my phone, I'd never be able to get back at that place. With that phone comes that great technology, but comes with some additional benefits potentially, is eventually we're going to get to where we're talking fully autonomous vehicles. Now that's a big step from where we're at now, where we have some vehicles that can move autonomously, that can park themselves, they can sense other vehicles, that sort of thing. You know, eventually, and I would not recommend doing this tomorrow morning on your way to class, don't sit behind the wheel while driving and read your textbook or do your homework. You should have done that last night. But eventually we'll get there. And you can see the technology is, you know, what they call vehicle to vehicle, V to V, or vehicle to infrastructure, V to I. Those two things, another couple acronyms you want to mention in your hiring spree. What can we do now to implement technology that can be used in the future? You know, so that we're not just building what I call dumb roads. And a perfect example, next slide. So here's that smart lane corridor that we were talking about on I-670. Couple of things, you know, we did the design of this. This is the first part-time shoulder use in Ohio. It's also the second variable speed corridor in Ohio. So the one thing to note is if anybody has driven this before, when the shoulder is on, which basically means when that green arrow is over that left-hand shoulder, the speed limit drops. In this particular image, it was down to 45. I think they've now changed that to 55 miles an hour. That is an enforceable speed, meaning if you're going 60 miles an hour, you can get ticketed. So it's non-advisory speed. But you have to train the drivers because they're no longer looking at the side of the road for a speed limit sign, now they're looking up. But the technology here is amazing. This project alone, we put 51 closed circuit television cameras in a 7-mile corridor. The idea behind this is all of those cameras are connected to a traffic management center. The operator in the traffic management center looks through this entire alignment from his computer screen to make sure nobody's broken down that left shoulder, or make sure that there's not any retread, rubber, anything that could be a problem. Because the last thing I want to do is come around this bend while using that shoulder and I hit a Volkswagen that's sitting up there on the side of the road who ran out of gas. So there was, you know, 9 miles of fiber run. Variable speed limits were implemented here. A lot of cool technology that was put in place for this project that will also set the table for future projects when we talk about technology. Next slide. One of our big challenges, and you want to hit this one, Danny, or you want me to?
I can do this once I unmute myself.
Okay.
All right, so everything Brian's been talking about is all things that when I got out of school 4 years ago, I probably wasn't thinking too much about it. I was like, I knew I wanted to be a roadway designer. I was like, you know what, I'm probably gonna be doing some roadway widening stuff, maybe some interchange reconstruction projects, but I wasn't really thinking about how technology all really plays into that. The other thing that plays into it, though, back to Brian's point about how we can't just build everything out so much, is funding. So we most of our clients are government clients, so taxpayer dollars, those are limited, and they've become even more limited. And so that's when technology even plays more into it, and also just trying to utilize the existing infrastructure that's already out there and enhance that and try to make the most of it. As you can see here, this is showing the state gas tax revenue as compared to the construction cost. And so that just kind of proves that construction cost is increasing. We're not having the money to do that. So we need to utilize technology and the existing infrastructure, which I'll go into a little bit more. This here is showing the fuel use of new vehicles in the United States, which just goes into where the funding comes from. The gas tax hasn't really been raised in Ohio until just in the past year. We passed a new bill that increased the gas tax a little bit, but as we'll get into again, that was based on usage, and that's decreased a lot, which was an unforeseen event when that gas tax was passed.
And to piggyback a little bit off what Danny's saying here, part of the problem is the technology that's being implemented is making our new vehicles more fuel efficient. You know, your 1993 Saturn, you know, was getting about 21 miles of the gallon, whereas now your Prius is getting 40 miles of the gallon. So you're not purchasing as much fuel, you're not feeding as much into that tax-based revenue for gas tax. So there's all kinds of issues. When Trump wants to build a wall around the world, where's he going to take the money from to do it? Those are the things that are competing interests then. So.
Yep. So us as engineers not only have to think about what's the how big can I build it, but how can I do it economically?
Yep.
And so one of those, I could keep going with this. So one of those another term here that you should write down is PBPD, performance-based practical design. Another way you'll hear about it is performance-based project development, and that's goes right into what I said about using the existing infrastructure more efficiently. And so what this shows here is an existing 1, 2, 3, 4 lane section, and it's over capacity, and the traffic analysis shows we need to add an additional lane. And so to do that, we can widen out so many feet using the standard 12-foot lanes, 10-foot shoulders, and that's going to cost a lot of money. Alternatively, we can use performance-based practical design or performance-based project development, reduce that shoulder width, reduce some of those lane widths, and minimize that widening, using a lot more of the existing pavement, reducing that widening, and getting a lot more bang for your buck. And that's the client's money.
So for context, this is actually I-71 southbound between Gemini and I-270. So if anybody who's driven that at 6 o'clock in the evening, it's a parking lot on the right side as the ramps from Gemini and Polaris are coming on. It's free flow speed on the left two lanes near the barrier, which causes a significant safety issue. So they need a lane of capacity, but to widen that facility would require extreme amount of money because there's multiple bridges to be impacted, replace, that sort of thing right away. So what you're looking at there is the existing typical section on the top. The alternative 2 and alternative 3 are variations of lane and shoulder widths that requires 0 widening, but to get that additional lane capacity. Alternative 1, standard concept, requires widening. So.
And so when we're looking at performance-based practical design, one thing that you need to look at is the safety analysis of that. So if you're going to say you're going to reduce the shoulder width from the standard width, you're going to reduce the lane widths, you need to justify that. And so that's where the safety analysis comes into it. And you can show, Brian, you might have to explain the details of this more.
So basically all this is showing is the gray bar is the safety performance of the existing, and that's the higher the number, the worse. Okay. What the other 3 bars are showing is alternatives 1, 2, and 3 are all better improvements to the existing facility from a safety perspective. But what this shows you too is, hit the next one. All right, there you go. Is that while alternative 1 actually has a slightly better annual crash reduction than alternatives 2 or 3, by the time you roll in the additional cost, that benefit cost ratio, it's actually the worst one. And so when we're looking at how do we spend our money, what's the best way to do it, all 3 I consider would say meet the purpose and need. In other words, they improve capacity and they improve safety. 1 does it a little bit better, but is more expensive, so we went with alternative 2 in this particular case. Coming soon to a project near you, that project will be constructed in the spring. So if
it's actually started.
Is it already started? Even better.
It is started.
Perfect.
So if you're driving 71 south to 315, you will see that this project is currently being constructed.
Perfect. All right, next slide, please. I think we're going to run out of time if we're not careful. So
Yeah, so I'll run quick through this one. It's just another example of performance-based practical design. This is a corridor in Akron, Ohio, 77 and State Route 8, where we needed an additional lane through the central interchange, and we only had so much width. If we widened out, we would have to replace 4 bridges. And if you go south down the corridor, it was an additional, say, 6 to 8 overhead bridges. So what we did was we proposed a performance-based practical design solution, reducing the lanes, reducing the shoulder width, and we were able to squeeze an additional lane through there and improve capacity, which I think ended up saving an estimated $65 million on the project. And this is another one that's going to be implemented next year.
So if you take my geometric design class this spring, I'm going to teach you how to follow the standards, and then I'm going to teach you how to break them, which is basically what PBPD, or performance-based practical design, is.
Mm-hmm.
All right, so the last trend that I want to touch on is the 5-letter evil word, COVID, that we've been dealing with. So obviously we've had to collaborate differently. That's what we're on right now. We use Teams and BNN, video conferencing, collaboration sites, that sort of thing. Remote working is definitely a thing now to deal with. It's a good thing. We just hired a person for our Columbus office that lives in Portland, Oregon. They're going to live in Portland, Oregon, but they're in our Columbus office. Explain that to me. I do real well in geography, but I think that's pretty far away from each other. Remote working works. Next slide. One thing that is a problem with remote working is it's changed our peak period. It's also changed our capacity and our congestion level. We talked about gas tax. We talked about user fees. I mean, the pictures obviously are extremely, exaggerated, but it does tell the tale that with remote working, if people are, I mean, I've put, in the past 3 weeks, I've put maybe 40 miles on my car in the entire 3 weeks. I used to put 40 miles a day driving to work. So next slide.
And then, so it's hard to design off of that when typically when we start a project, you're going to go out there and get traffic counts, figure out what the existing conditions are, and determine a solution from there. But obviously, if there's no traffic, it's hard to do that. So there's innovative ways now that we're trying to work on to collect that data. And so we've thrown a lot of information at you, but how does this affect you? What does it mean? And really what we're trying to do is drive the point across that what you're learning in school is all going to be applicable as far as the engineering principles, the design standards, but you're going to have to bring other aspects into it as far as technology, and just having a mindset towards improved efficiency and also keeping fiscal constraints in mind. Additionally, you're going to have like a multidiscipline mindset. So if you're going to be a roadway designer, it's good to have that traffic mindset or that safety mindset. You're going to be an expert in one thing, most likely, but if you have an understanding of the other things, it'll make you even more well-versed in what your specialty is, and being able to think outside the box, come up with innovative ideas, and so on. And technology is another one that's just more and more going to be playing into it. That being said, you always have to remember the big picture. The ultimate goal of most of these projects is improving safety and increasing capacity, improving congestion. So that's the big picture. It just may be achieved a little bit different than the old days as far as widening, keeping the full standards, using that technology that we've talked about, those innovative intersections and interchanges, and just keeping that that innovative mindset and thinking outside the box.
So yeah, so hopefully this was worthwhile to you. Like I said, very subtly, hopefully, we promoted BNN. But this is the stuff that we do. This is the stuff that we get to play with. So if you're sitting in a class, except for your geometric design class, which hopefully you're sitting in the spring, if you're sitting in your class and you're bored, be thinking bigger. Think bigger than what the professor's telling you. Think about how would you apply it if you're going into transportation engineering, and challenge your professors. I'd be curious to see how many of them would be able to do some of this stuff, certainly. I say that because I am a professor. So, Daniel, I think with that, kick it back to you. Appreciate the time.
Thank you.
Perfect. Thanks. Thanks, Brian and Dan. No questions though. Just check, double check, give a minute for questions. I think people would have popped in with them if they had them in the chat during it. I just wanted to check. I have a question. Do one of you play City Skylines? Got this little screenshot here at the end.
I do not, but I was going to say this. I was going to joke that this is an actual project, but it does feel like that sometimes.
It's a rendering, yeah, very professional.
Yeah, it does. I mean, it does feel like that sometimes when you're kind of doing preliminary engineering, you can come up with those innovative ideas. I mean, there's the standard solutions for everything, but once you come up with that innovative idea, it is kind of like playing a game like that sometimes.
And then trying to sell it. And then trying to sell it to the public's another one. So, yep,
yeah,
absolutely.
Sarah asks if this recording is going to be available. Sarah, I will figure out how to post these on our website. It's something I want to get going this semester. So check u.osu.edu/ASCE in the next couple of days. I'll try to get that hosted up there.
Maybe he can substitute my voice out for someone else's. It'd be good. Yeah, George Clooney or somebody.
Absolutely not.
Yeah.
You did a great job. Okay, normally this is where I call for a big round of applause, but the best we can do is clap emojis. So a poor substitute for the real thing, but thank you guys so much for presenting. It was very informative, both about BNN and some of the trends in the industry. Thanks, guys. Okay, I've got a couple outro things to go over here, so let me pop it back to our presentation. Okay, just one more slide. Kind of a wall of text, but don't get overwhelmed. 2 topics for next month. So next month meaning before our next meeting. Watch out for an update on our t-shirt situation. We're going to have a system in place for people to order them, and we're going to figure out how you guys are going to do pickup. With COVID and everything, you know, nobody's on campus, and people are not always close to campus. So we'll at least have a pickup on campus for those who are able to make it there, and we'll figure out something if you're far away or unable to leave your housing for whatever reason. We'll make it work. So watch out for that. We don't have a solid plan in place yet, but we just got our designs, so that was step 1. We'll have an email go out about that once everything's finalized. And then the second part over here on the right is that elections are coming up. So traditionally, our 3rd general body meeting, so for this time it's going to be October, we will have our elections, and usually that's something that we do in person. We'd have everyone who wants to run for a certain position get a chance to speak. They stand up, they talk to the room, and then once everybody's had their chance to talk to their constituents, so to speak, everyone just does a raise of hands, and we count them up and we say, all right, this is who has what position. But that's going to look a little different this year because, of course, we can't meet in the classroom. So we're figuring out how voting is going to work. It could end up being before the meeting. We could collect votes over a course of a week, and then present the winners at the meeting. Or maybe at the meeting we'll have people speak, we'll record what they have to say, and then we'll send out the polling after the meeting for like the week after. Or we could figure out a way to do it live. So still figuring that out as well. We've got a month to get that sorted. But in the meantime, what I encourage all of you to do is go on our website. I know I've been plugging the website a lot today. Gosh, there's a lot on there. But u.osu.edu, I believe it's /contact is where you're going to find this stuff. It's just under the Contact Us page. It's just a list of all of our positions. It doesn't describe them in any great detail. It just has each of them listed and who is the current position holder. But it gives you an idea of the sorts of positions that we have in place. And if one really, the idea of one, the title really strikes you, you know who currently holds it, and maybe you can reach out and talk to them a bit about what it's like. So watch for an email about that. I'm going to send something once we figure out how voting is going to work with a summary of that and about all of our different positions and what they do. So I know we have a couple of our officers are leaving at least this the end of this year, so we'll have at least 2 positions to fill, I know, but we always encourage involvement in any capacity. And I got involved myself as a freshman representative. It was a new position created for undergraduate engagement, and I started going to the officer meetings, and then that's how I became president. So if you want my job one day, consider looking for some of those entry-level positions. But get excited about getting a position with ASCE. We're not going to pay you. But, get excited about getting a position with ASCE, and look for something about that in the next month, how voting is going to work. Okay, that's all I have for you guys. Thank you to you guys, and thank you again to our presenters. This was great. And I will stick around for a few minutes. Officers, please stick around too, but I'll stick around a little bit, specifically just to answer some questions if anybody has anything to ask me. But with that, you guys have a great evening. See ya.